This is the screencast for section 5.4, example 5. We're going to use half angle identities. Now if you remember, double angle identities look very similar to this. Now these are half angle identities and they have a square root around them. Maybe you can figure out how those are related on your own. We're going to use half angle identities in example 5 to solve for the sine squared of x equals 2 sine squared of x over 2. So another situation where we don't have a proof. They are not always equal, the left side and the right side here, but there are a few x values where they are equal, so their graphs will cross. I'm going to first set my equation equal to 0. So I have sine squared of x, I subtract 2 sine squared of x over 2 from both sides. Now I've got a mess. I've got a sine squared, but of x over 2. And I really have a sine squared of x here. Let's see. Well, I want to get rid of this x over 2 business. That's very difficult for me to work with. I like something that just has theta in there, or x in there, or u in there, or alpha, or beta, or whatever. If you remember, sine squared of x over 2 is really the sine of x over 2 squared. So I have the sine of a half angle squared. That half angle is going to be plus or minus the square root of 1 minus cosine of, not u, x over 2. Well, lucky for me, squaring a square root will simplify out. Plus, if I squared a positive, my result would be positive. If I squared a negative, my result would be positive. So I don't have to worry about the plus or minus. Oops, that was a minus sign. Sorry about that. So now I have the sine squared of x minus 2 times 1 minus cosine of x all over 2 equals 0. Ooh, another convenient thing, the 2's cancel out. Now I have sine squared of x minus 1 plus cosine of x because I'm subtracting this quantity. Well, I can't factor this yet because I have a sine squared and a plain old cosine, but I do know from my Pythagorean identities that sine squared is 1 minus cosine squared. So now 1 minus 1 will be 0. So I really only have negative cosine squared of x plus cosine of x equals 0. So I can factor out a negative cosine of x, which leaves me with cosine of x minus 1 on the inside. So now I know that the negative cosine of x has to equal 0, or cosine of x minus 1 has to equal 0. Well, let's see. If I divide both sides by negative here, it really just means that cosine of x has to equal 0. Or here, if I take cosine of x and add 1 to both sides, cosine of x equals 1. So the values of x where cosine is 0 are pi over 2 and 3 pi over 2 from the unit circle. The values of cosine of x, the x values for cosine of x where cosine is 1, that's just 0. So in increasing order around the circle, the values, the x values that make the left side equal to the right side are 0, pi over 2, and 3 pi over 2. Done. The now try problem number 43. A very similar situation. On the left side I have cosine squared, on the right side I have sine squared of a half angle. So I'm going to first set the equation equal to 0 by subtracting sine squared of x over 2 from both sides. Now I have a square of a half angle. So I'm going to square the expression for the identity for my half angle, plus or minus the square root of 1 minus cosine of x all over 2. And then now I'm squaring a square root, so that disappears. What does not disappear this time is that denominator. So what I'm going to do is multiply both sides by 2, which doesn't hurt the right side at all because 0 times 2 still 0. Now I have 2 cosine squared of x minus, let's see, 2 is getting multiplied by everything in here. So those 2's will cancel, but I'm still subtracting 1 and subtracting negative cosine of x, so that's going to be plus cosine of x. Now I have a situation where I will want to use the Pythagorean theorem, or the quadratic formula. I can make cosine of x u, but I think I'm getting pretty comfortable with writing cosine of x every time, so I'm just going to say the cosine of x equals, let's see, opposite of b plus or minus the square root of b squared minus 4ac all over 2a, which, oh, I've actually dealt with this before. This is the cosine of x equals 1/2 or -1. After you work all that out, it'll look very similar to example 4. So the values of x that make cosine 1/2 are pi over 3 and 5 pi over 3 in quadrants 1 and 4. The values of x that make cosine -1, well, that's just pi. So in increasing order, x equals pi over 3 in quadrant 1, pi on the negative x-axis, and then 5 pi over 3 in quadrant 4.